I have another problem here. This problem is 9.11. Here he has given me a cantilever beam. Okay. What he says, determine the deflection at the end of the cantilever of the steel cantilever beam at point B, he says here, as shown in the figure below. Assume the modulus of elasticity of steel is 207 GPa, gigapascal. Okay. Here he has given me the dimensions. The rectangular cross section 60 mm high. That is, this height is how much? 60 mm. This is how much? By 20 mm wide. This is 20 mm wide. Right. So now he wants me to find out what deflection at point B. So what is the general equation? General equation is W is equal to, this was already derived, W x cube by 6 EI minus, not minus, it is plus WL square by 2 EI into X minus WL cube by 3 EI. This is the general formula. Okay, this is the general formula for deflection of the beam at free end when a load of concentrated load or point load is applied at the free end. Okay. So now what is happening? He wants at this point, isn't it? So if I have a section over here like this, let us have a section over here. If this is x, and this is actually x, this is the way we have derived this equation. If this is x, what will happen now when this goes over here? What will happen to the value of the x? Y is maximum at x is equal to 0. When it goes, it becomes 0. Then what happens? This becomes 0, means this is gone, isn't it? So I am left with what? Y max is equal to minus WL cube by 3EI. This minus sign is only indicating that you are down. Okay. So now first what I need to do, I need to find out the value of I. What is the value of I? Let me calculate it over here. I is equal to BD cube by 12. B is how much? Ashreen, multiplied by depth is 16 cube divided by 12. This gives me how much? This gives me a value of 36 followed by 4 zeros. Okay. If I want to write it in 10 to the power of x fashion, it's a small number, let me write it. 36 followed by 4 zeros, millimeter to the power of 4. This is the value of E. Okay. Now I anyway know L. What is the value of L? 1.2 meters, is it not? L is equal to 1.2 into 10 cube millimeter. Let me write it. Okay. So now let us just substitute the value to get Y max. Y max is equal to minus of W is how much? 15 kilonewton, sorry, 1.5 kilonewton. That is 1.5 into 10 cube newtons. 1.5 into 10 cube multiplied by L is 1.2 into 10 cube. This pen is not good. Let me change the pen. Okay, divided by 3 multiplied by E is how much? 207 gigapascal. 207 into 10 cube megapascal, is it not? Multiplied by I. I is how much? 36 followed by 4 zeros. Now see here what are the things happening. So many things are getting cancelled out. This 10 cube goes with this 10 cube, this 10 cube goes with these 3 zeros. So it's very easy, just let's do it out. Once calculate 1.5 multiplied by 1.2 divided by 3 divided by 20. Sorry, not 20. 1.5 multiplied by 1.2 divided by 6. Divided by 3 divided by 207 okay, divided by 360. That gives me how much? It gives me a very small number. See, I have to put 3 here. This is L cube is there. Okay, it will give me a small number. Y maximum is equal to 12 millimeter. Okay, it is how much? 12 millimeter. This is the value of Y maximum, that is at the free end. Okay. So you can remember the formula, minus WL cube by 3EI. For simply supported beam, it is WL cube by 48EI. Okay, this is for the deflection. I am not talking about slope. I am only talking about deflection. Okay.